Bayesian probability is an interpretation of the concept of probability, in which, instead of frequency or propensity of some phenomenon, probability is interpreted as reasonable expectation representing a state of knowledge or as quantification of a personal belief. The Bayesian interpretation of probability can be seen as an extension of propositional logic that enables reasoning with hypotheses, that is, with propositions whose truth or falsity is unknown. In the Bayesian view, a probability is assigned to a hypothesis, whereas under frequentist inference, a hypothesis is typically tested without being assigned a probability. Bayesian probability belongs to the category of evidential probabilities. To evaluate the probability of a hypothesis, the Bayesian probabilist specifies a prior probability. This, in turn, is then updated to a posterior probability in the light of new, relevant data, evidence. The Bayesian interpretation provides a standard set of procedures and formulae to perform this calculation. The term Bayesian derives from the 18th century mathematician and theologian Thomas Bayes, who provided the first mathematical treatment of a non-trivial problem of statistical data analysis using what is now known as Bayesian inference. 131 Mathematician Pierre-Simon Laplace pioneered and popularized what is now called Bayesian probability. 97 to 98 Bayesian methods are characterized by concepts and procedures as follows. The use of random variables, or more generally unknown quantities, to model all sources of uncertainty in statistical models including uncertainty resulting from lack of information. See also aleatoric and epistemic uncertainty. The need to determine the prior probability distribution taking into account the available, prior information. The sequential use of Bayes' formula. When more data become available, calculate the posterior distribution using Bayes' formula. Subsequently, the posterior distribution becomes the next prior. While for the frequentist, a hypothesis is a proposition, which must be either true or false, so that the frequentist probability of a hypothesis is either 0 or 1. In Bayesian statistics, the probability that can be assigned to a hypothesis can also be in a range from 0 to 1 if the truth value is uncertain. History. The term Bayesian derives from Thomas Bayes, 1702 to 1761, who proved a special case of what is now called Bayes' theorem in a paper titled An Essay Toward Solving a Problem in the Doctrine of Chances. In that special case, the prior and posterior distributions were beta distributions and the data came from Bernoulli trials. It was Pierre-Simon Laplace, 1749 to 1827, who introduced a general version of the theorem and used it to approach problems in celestial mechanics, medical statistics, reliability, and jurisprudence. Early Bayesian inference, which used uniform priors following Laplace's principle of insufficient reason, was called inverse probability, because it infers backwards from observations to parameters, or from effects to causes. After the 1920s, inverse probability was largely supplanted by a collection of methods that came to be called frequentist statistics. In the 20th century, the ideas of Laplace developed in two directions, giving rise to objective and subjective currents in Bayesian practice. Harold Jeffreys' theory of probability, first published in 1939, played an important role in the revival of the Bayesian view of probability, followed by works by Abraham Wald, 1950, and Leonard J. Savage, 1954. The adjective Bayesian itself dates to the 1950s. The derived Bayesianism, neo-Bayesianism is of 1960s coinage. In the objectivist stream, the statistical analysis depends on only the model assumed and the data analyzed. No subjective decisions need to be involved. In contrast, subjectivist statisticians deny the possibility of fully objective analysis for the general case. In the 1980s, there was a dramatic growth in research and applications of Bayesian methods, mostly attributed to the discovery of Markov chain Monte Carlo methods and the consequent removal of many of the computational problems, and to an increasing interest in non-standard, complex applications. While frequentist statistics remains strong, as seen by the fact that most undergraduate teaching is still based on it, Bayesian methods are widely accepted and used, for example, in the field of machine learning.